Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
Okay, so I'm logged into the mastered server, basically workstation, not mastered. But as we discussed last time, master server and work server is in same machine. Sorry, master and workstation is in same machines. So that is how it is. So I have become root now. That is where the workstation is set up. I'll just check kubectl get nodes my working or not, and it's ready. Cluster is ready. So now once things are ready, you will work on
This
few
is master,
resources.
no?
Th- This
This
is
is
a
master.
mastered, but workstation I set it up in the same machine. No?
Okay.
So after the cluster is there, this is my workstation. Forget about master and worker because workstation kubectl is connecting to the API server. Okay. So now
Okay.
what to do?
Okay.
So now here we have a master. Here we have a worker. So next thing is what to do. So you have to create uh, resources. Which are the resources? So I don't know. So I will try to learn myself only. kubectl enter. These are the commands, you need to practice it. So one of the command which will tell me which are the resources Kubernetes is having availability. So see, these are the resources. So these are the resources, right? So out of which most
Yes.
important one we'll cover in this session. So do you know AWS or Azure?
Azure, I know. AWS also have idea. Yeah.
Yeah. And then here I will coordinate with
Rajesh, one
Kubernetes.
doubt I have. Can I ask?
Yeah. Yeah.
So yesterday I went through two videos again. Now, inside the Kubernetes, we are using Docker. That will be connecting to API server, right? Am I right? In architecture, at one point we are using Docker,
Mhm.
right?
Yeah.
Uh,
So here you need to understand that what is a pod? What is a pod? So
yeah, I mean in
pod
pod,
base.
yes.
So pod is a understand that pod is a logical unit. Logical unit. It's not consuming CPU and RAM. It's a logical unit to contain containers. Okay, that is all. So pod is instantiated by kubelet. Okay, kubelet. Kubelet, which is a kind of agent which is running in the worker. Okay, so that is the thing. Now pod has a container. So container in the pod, container by Docker or containerd. Many options are there by the way. Pod has a container. Container is created by Docker or containerd.
Oh, okay. So this pod, inside pod, the container which consists of our project will be created by Docker or any other one like
Container
container D.
runtime environment. Yeah.
Oh,
Okay. So that is up here. So pod is a logical unit in Kubernetes. So let's try to some correlate here Azure versus Kubernetes. So here when you say compute unit, we call it VMs. Okay. In Kubernetes, we call it a pod. Understand that. When you want multiple VMs, what you do? You create auto scaling group, ASG, correct? Na? Scaling set or something. So
yes.
here we call it deployment.
Oh, okay.
Here we in Kubernetes, in AWS, Azure, you create a load balancer, correct? Load
Yes,
balancer.
yes.
So here we create service.
Oh, okay. That is API, sir. this service will connect to API server, right?
Yeah, API, that service is a name of resources.
Okay.
See, everything is resources. If you go to AWS also, see resources. There's hundreds of
Resource.
resources. So like that in Kubernetes, see in AWS you got a good UI, but in Kubernetes these resources just now I showed you know left side which are
Yes.
the resource, these are the so you can say in let's say AWS have 5,000 features and
Uh-huh.
Kubernetes have close to 70-80 features actually, and it is growing
Oh,
actually.
okay.
Here these are the features, resources we call it, 24 features. Got it?
Okay. Now I understood. Okay.
Yeah. So these are the resources, okay, in Kubernetes. The only thing is we have to create it using command line or YAML file. Okay. So these resources, because it's API resources, so you do the CRUD. Okay. CRUD means CRUD. So
Okay.
create resources, read resources, update
Update.
resources, and
Delete.
delete resource. Yeah. So these are the 4 things you can do through command line or YAML. Okay.
Okay, so Rajesh, this master, whatever this master node will be there, it will dynamically, it will allot, I mean, to the child. That's what master and slave. It will directly allot. That's what it will do. No, it will regulate.
Yeah, it will regulate. So this is you. Okay. I'll put it in a simple way. This is you,
Mm.
and this
Mm.
is your laptop. Okay. This is your laptop. And here you have a kubelet installed, and this is a cluster. So clustered, we have one server which is called master server, and then remaining
Okay.
are worker server. Worker server where the pod for your application runs. Okay, so this whole clusters managed by this master. But who manage the master? You will manage. So there is one
Mm.
API server who receive all this. Yesterday, last session we discussed.
Mm.
No, this is the
Yes.
API
Yes.
server address. So
Yes.
kubelet
Yes.
need to be configured. So theoretically, see, understand that they all talk to each other through API. Mind it. API means I'll simplify IP address and port number. Okay. So theoretically, this is the architecture. Okay. This is your laptop. Kubelet, kubectl will be set up here. And this is the master. This is the worker. And last session, I discussed what are the components you have in the master and worker.
Yes.
Now, what you will do only 2 things. You will write a command. You will write a command or YAML file. So that is what I was trying to tell you. You will write a command and YAML file and say, hey, I want to create, I want to read, I want to update, I want to delete. But what? These resources. Simple
Oh,
one, these are the resources.
okay.
But if you think technically, don't you think these all components can be in one node itself? Because they talk to API, right? IP address and port
Yes.
number. So
Mm.
workstation, master, and worker can be in a one
Mm.
machine also. Because
Yes.
see, this worker, he is there because of certain software. Workstation is there because of certain software and configuration. So people can configure everything in one also. That is called mini queue. Mini queue here. Okay. Mini queue is a desktop like local Kubernetes. Everything is set up in one VM only. Got it?
Got.
Yeah, but I am having 2 machines. What I did, these 2 machines I set up on one machine only. Why? Because I want to be inside cluster so I can connect directly the pod. If I are outside, you cannot connect. That is a problem. Got it?
Oh, got it. Got it.
So what I am going to do? CRUD for what resources? Pod deployment service. So first I will create a namespace. Namespace. What is a namespace? So in your company, let's say your company named is company X. Company X has a multiple projects, right? And each projects you have a multiple engineers, correct? No?
Yes.
Correct. So
Yes, yes.
so it's not like they manage entire organization one being one family. No, multiple projects is there, multiple departments are there for efficient handling the resources. Correct, no? So that is how something we clustering also we do that. How can we divide the cluster into multiple logical unit for different projects and different environment? So in Kubernetes, we call it a namespace. Okay, namespace is a way to logically define the cluster and their resources. Resources means CPU and RAM and storage. Okay, so logically decide their storage in a different projects. So Kubernetes has given you multiple namespaces. You see here, multiple namespaces. Default namespace, node namespace, public, and system. System namespace, all the component of master and worker is running. Let me show you. Get ports -n means namespace. These all are the master component and worker component. Okay, which namespace is running? System.
System.
And
This is
if you
master and
you are not in master, don't think you are querying from your laptop to API server. API server knows
oh,
everything about the cluster. You're just getting information, nothing else. Okay.
okay,
You are just asking API server, hey API server, give me, get, read, create, update, delete, all
oh,
these things you are requesting.
okay,
So here these are the pods running in the kube system namespace. If you are not specifying -n, that will be part of the default. See default, no resources found in default.
okay.
So can I create first the namespace for my project? It's very simple,
Yes,
okay? Don't complicate. Create, read, update, and delete. I would suggest you spend some time, 20-30 minutes, to get comfortable with these all commands. Read it. These are self-explanatory. Anyways, I'll show you the demo for this. So what I want to create a namespace. How do I do that? So I'm going to create through command line. Next demo will be CMD. So kubectl create create what namespace shortcut. Okay, what namespace? Dev team. I will create qn. So now get kubectl get namespace. I created. Here, dev and qa created. Correct? Huh? Now I created. I get it. I can also describe, also detail it. Describe ns dev. This is the detailing. Now I can also modify, also edit, right? CRUD. Now many things you will get to know slowly. So till you get to know the confidence, what to modify, what to not modify. Modify the labels blindly. Every resources in Kubernetes will have a label and you can modify. Mind it, it's YAML file. You'll need to be little bit aware of YAML. So here watch team this is for dev. I labeled it, save it. See edited, describe. Look at this. I edited, I created, I read it, I edited, and I delete it. So finally, bye bye. So delete, simple, not complicating too much. And sorry, done. See, dev is gone. Are you understanding, all of you?
yes, yes, yes,
So this is something namespace I created. Now what I want to create pod. Pod is equal to compute unit. Pod will have a container. So this I'll create through YAML file. What to do? I need YAML file. You can Google it, you'll get it. A lot of YAML file, but I have my own. So you can follow if you want. So Kubernetes pod examples here. So this is the pod examples. Okay. So here you want pod. This is the YAML file for it. Hey, what do you want pod? What is the API version for that pod resources v1? What is the name? Rajesh. Pod name. Label with hello world. What is the pod will contain? So pod will contain containers. Okay. Just give me 2 seconds. Someone has come.
Okay.
This conference will
Okay.
now be
Let's get
recorded.
started.
Uh,
Hello.
yeah, I am there.
Hello. Yeah. Okay. So I want the pod. So pod can contain containers. Yes, means multiple also. Right now only one. This is my image. You can take it up any web images or to practice it. This image I created from the Nginx image actually. Okay.
Okay.
So this is something. What I will do, vi pod.yaml. Here I'm creating a pod. So what to do? So kubectl create -f pod.yaml. I'm creating a default. And you see if I try to create same pod, that is already exist. I can create another namespace though. I can do that. See here. So I got a two pods. This is a one pod, Rajesh, and there is a one more pod I created. One more pod I created, QA pod. Two pod I got created.
So you mean to say that in a single workstation, we can create as many as pods if required, but with the same name, we can do it in a different what namespace, but in same namespace, we cannot create uh,
No,
same
no, no.
same.
Your explanation is 100% wrong. Again, I'm saying pod is created here, here, here. Workstation
Oh,
means you are just requesting API server. Hey, API
okay.
server, create.
Okay.
I repeat again, you are just requesting API server.
Okay.
Everything is done by
Okay.
API server. The architecture
Okay.
discussion, if you remember that.
Yeah, yeah.
Got it?
Got it.
So
Yes, yes,
you are
got it.
doing
No.
nothing but querying actually. Okay. So here you got a pod. So again, CRUD operations I'll do. So I created a pod. I get this pod. After that, I will edit the pod. So here, edit pod Rajesh. Now, when you specify no hyphen n, that means default. Okay. So this is the pod YAML file. I just said many things you need to learn. Slowly you will get to used to it. But right now, because you don't want to spoil this anything, blindly you can modify labels. So this is a application, no, team app is there, no, team DevOps. I edited it. Now you want to see that pod, right? So describe same command pattern. You need to remember nothing great about it, Rajesh. Okay. And see here somewhere here. Finally, I edited it and now I am going to delete that. So how can we delete that? So delete pod Rajesh, but I will delete QA1, not a default one. So this default one is still there, but QA1 I deleted. Get pods hyphen n QA. See, nothing is there. Default one is still there. So this is how you do the CRUD: create, read, update, and delete pod. So far, so good. Hello.
Yeah, I'm there. I'm there. I'm listening. Yeah.
Yeah. Now the question is, how do we use the pod? I repeat, I told you very clearly, pod, when you think it's a compute unit, it has a container. So you can access it through IP address, just like a VM. How can you access? So kubectl get, I'm inside a cluster because of this region only. Pods hyphen o wide. So this will give you short information. Describe will give you so much information. This is the pod IP address running in this node, worker node. So can we curl this one? Because of this, I set up workstation inside a cluster. If you do curl from outside, you will not be able to access. See that? So I got to access this pod. Welcome to Debugschool version 1. That's an Nginx pod with customized engine and index.php HTML. Got it?
Got it. Uh-huh.
So this is the access. Now you say, how can I go inside a container? So I'll show you that. QCTL.
Rajesh, this is public IP, no? From outside, we can
No,
curl using curl.
no, this is a clustered IP. This is a see. This is a clustered IP accessible only within a cluster, not public IP address.
Okay.
It's like you can say private IP address of VM, right? VM also get a two IP address, no?
Yes,
Public
yes,
and
yes,
private.
yes.
So it's like a
Yes.
private IP address which is not accessible outside of the cluster.
Okay.
Real IP
Got it.
address. So here kubectl, I want to go inside a container. How? Same Docker command if you know something like that. So here, if you want to go inside a container, where are you, Ram? Where are you, Ram? You are inside a container of
Yeah,
that
I'm inside
particular
a
pod.
container. Yes.
Exit. So here you can access from outside also within a cluster, and I can go inside a container of that particular pod
Container.
also. Yeah.
Mm.
You want to see the logs very well. You can see that get logs. So here, oh sorry, get pods, get logs, Rajesh. Okay. What is the problem? kubectl log actually, not logs. Log. There is a problem.
Mm.
Oh, sorry. Not get log. Wrong command. kubectl got get kubectl logs Rajesh. See, I access only one time, so one log is coming. If I hit two times, then two logs is coming. Like
Oh,
that. Got it?
okay. Got it.
So this is the logs of the container. So this is the pod. Okay. So it's like a VM, the one which you got it.
Okay.
So now the
Got
question
it.
is, you don't want one pod, you want thousands of pod. How do we get it? So that for that we have a four features. I mean deployment. Deployment is another resources. So what is the use of it? So deployments primarily have a four features. One is replications. That means you can get many pods. One is controller feature is also there. That means if you say 100, this will be 100, not 99, not 9101. So this will be maintaining that desire. And then
Okay.
upgrade feature, rollout feature is also there. Rollback feature is also there. Many features are there for the deployments. So now the question is, I want to create a deployment. How do I do that? So first thing I did through command line, second I work with the YAML file. Pattern is same, okay? So you can work with the deployment YAML file again, but this time we'll try command line. So how do we do that? I don't know the command. So how do I learn? So I'll teach you the techniques. What I want, I want to create a service. Oh, sorry. I want to create a deployment. So qctl, enter, uh, create. Okay. So create
Okay.
and -h. See
I
here,
see.
so many resources I can create. What do you want to create? Deployment. So here, one is deployment, -h. This is a technique to learn yourself. Don't need to ask anyone. You can learn yourself. See here. And then you got few examples for it. So what do you want? I want to create deployment and example commands. You have it. So here you see, create deployment, name of the deployment, image. I will go for mine. And how many replicas you want? 5. And you see here, clear the screen, kubectl get deploy. In the default namespace, there is no deployment. See, I created, and here I got it, and 5 pods I should be having from that. These are the first 5 pod. You have it. So simple. So this is called replication feature. You want to more, you want to do more, you can scale it, edit that deployment, edit, deploy. What was the deployment name? My hyphen dep.
Okay.
So
Hi.
what do you want?
Email.
5 to 20, and you see here 20. See magic.
Okay.
You want I'll teach you another way. Scale is a one more command. You can scale it. -h. One, two, and name of the deployment, my dep. So this will easily do that stuff. So right now, how many pods you have? 20.
20
Two pod,
watts. Yeah.
2 pod. Now 2 pod. See, all got terminated. Correct now? You want
Yes.
30 pod. Just put it up
Edit.
30. Edit
Okay.
also, and this command also will work. 30. Done. See. So it's so simple. So simple here. All the containers got deployed. Now you want to make it 3. Okay. Again, I'm not waiting for it though. I have only one worker, mind it. See here, terminated, only 2 is pending. Let's wait for it. All terminated except 2. Are you understanding? Hello? Hello?
Yeah, yeah. I'm
This is
seeing.
called replication feature. Now
Okay.
controller means what? So what is your desire? My desire is 3. And if I manually delete that, look at this age, okay? Age of the pod. And manually I'm trying to delete, okay, pod. Manually. And you see out of 3 desire, 2 I'm deleted. And you see the what will happen. Did you notice something?
It's still there.
Age, look at this. I deleted it, but it got created. So that feature you have in the deployment.
Oh, okay. Got it.
Yeah. So these are the some of the features. If you want too many pods, replication feature, deployment feature, all this thing, you can use a deployment.
Okay, so even if you're deleting also, it will dynamically again recreate. I mean, it will delete and
That's
it
what the
will
controller
recreate.
means. Remember, I told
Oh,
you Kubernetes will help you to match your desire. Whatever is your desire, Kubernetes will help you for that.
okay. Got it.
Yeah. So that is something which is a deployment. So you can play with it deployment. So here you can come to this place, Kubernetes deployment, just type it. And this is the strategy. This is example and few more things are there. So just, this is a strategy of the example. So just check it out. It will help you to do that. Okay. So now what is the next services? So next services is service. What is service? It's a load balancer. For what? Balancing the pod. Let's understand this way. Okay. So here, let's have a 2 service. So here, let's understand you have a front end pod here, 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 and then you have a back end pod here, here, here. So how many load balancer you needed? So I need a load balancer, one for front end, correct now?
2 for backend.
One
3 for
for, so,
front
and one for the back end, correct now?
end. Yes.
So 2 service needed, 2 load balancer needed. So here,
Yes.
this backend services. So front end, if end user, this is the end user, they will hit the service, and service will hit this, and then accordingly it will go to the.
Okay,
So load
so
balance.
the user will hit a load balancer IP. Okay.
Hmm. So user will hit the load balancer IP of front end service. Okay. So how do we create it? So there are 3 level of load balancer which we have. Level of load balancer. Like I'll tell you in a simple way. When you create a load balancer on Azure or AWS, you have an internal load balancer and then external load balancer. Correct now? So internal will be accessible within a network, external will be accessible outside of a network. Right now. So similarly, we have a one
Yes.
load balancer. In Kubernetes, we call it service, but I'm using the simple word so you don't get confused. Okay.
Okay.
So here
Okay.
3 level of service we have: clustered IP, then node port, and then load balancer. Load balancer. So 3 level of load balancer which have. So clustered IP service, this load balancer accessible inside a cluster only. Remember, you cannot access from outside. If you want certain service to be accessible at the port of the node, I repeat, port of the node, that means this port of the node worker. Okay, then you have to use this one, node port,
Clusterized.
access a service at port of the worker. Okay, and this one is basically, this is related to cloud. That means this is creating AWS load balancer or Azure load balancer and balance all worker, because you did this one, no? So what you did, at each worker you expose at a certain port. So this
Yes.
load balancer will create a external load balancer on a
Okay.
AWS level or Azure level and balance
Mhm.
all the workers. In
Workers.
simple way I'm
Using the
putting,
port of using node ports.
using node port. Yes. So these two I can show you right now. This is not integrations. So how do we create a service? I don't know. So what I'll do, same techniques, create service -h. See that what you want, clustered IP, load balancer, node port. External name you can leave it because that required some domain services. So we don't need it right now. So which one you want to go for it? So first I'll go for clustered IP.
Cluster IP.
Yeah. Yeah. So -h, remember, I don't know the things, but I got to know the commands. I will use this. So by default is a clustered IP. So what do you want? Create what? Service. Okay. Type clustered IP. Name. Okay. What is the service port number? This one. Container port number. 8080. No, mine is 80. Remember that. I am accessing all of my pod on the 80 port. Let me show you. -o wide. See that these are the 3 ports, right? So kubectl, http, 80 port, right? So 80 port. So this is the container port, pod port, and this is the
Okay.
service port. So how many
Service port.
service we have? Yeah, how many service you have? kubectl, get,
Okay.
svc. So mind it, I did not create any service, but I have one service. One service means load balancer. How come? I don't know. You have to find out this for me. Okay. Whenever you set up a cluster, this Kubernetes service, you will get it by default. You need to find out why this is service there. What is the use cases of it and all. By the way, I have come to create my service. And here I created my service. Here it is, my CS. I created a my service here, that this service I'm expecting the load balancing these 3 pods. Okay. Get pods. So these 3 pods should be load balancing. Can I check whether load balancing is happening or not? So let me check that. Describe svc my CS. And here, if it is load balancing, this one will be updated. This called endpoint. But I see that it's not updated. Three IP address should be there in the endpoints, but it's not there. So what is the
Yes.
reason for it? So there is a problem here. What is the problem? I'll tell you. So here kubectl get pods hyphen show labels. Show labels. What is the labels you see? And now I want to describe the. what is happening? Understand that simple formula. These three pods, these three pods will be load balanced by service only and only. I repeat, only and only if the selector logs, selector labels are matching. So selector label of the service must match, must match with the labels of
Oh,
pod. Is it matching?
no, it is my
It's a
and
CS.
hyphen def, no? Oh,
Yeah.
yeah,
So what I'll
different.
do, yeah, different. So I'll modify this one. This I'll do manually right now for your learning, but typically we have automation in place. I'll show you that. So edit and depth. So go and change the labels, selector labels. I repeat, selector labels. Depth, depth. I change it, save it, and now coming. See. So that means now if you hit the service, okay, this is a service IP address, curl HTTP. What is the service port number? 5678. 5678. See, one of the pod, the traffic is getting diverted. So now this I showed you so you can learn how the load balancing works in Kubernetes. But you know what? There is a magical command which will do all this manually, automatically. What is the magical command? kubectl expose. Okay, hyphen h. So this will do magically everything. Okay, so let me do that. So here I'll create a load balancer, expose rc, no deployment, and my dep, service port number 8080. This time role balancer port I'm putting 85678. Also you can put it up if you're getting confused, but the name has to be changed. Name Raju. Okay, done. So here I created another one. So kubectl get svc. This is the Raju, and you see this time I don't need to modify the labels. Automatically it will happen. So 5678. See, export command to save your time and effort, but I wanted to show you how it works. Now, so this is the cluster IP. This IP address will not be accessible from outside. So what we do? So we have to specify node port. Node port. How do we do that? Hyphen type node port N and P capital. Remember. So here name I have to change it. NP. Everything will be same. Created, and now see that three service I created, three load balancer created using the same
Mm,
pod, but technically it should be different deployments, mind it. So this is the node
mm,
port. Now you see this is the internal cluster IP address, but node
mm,
port is this one. So that
mm.
means what is the IP address of my node? My IP address of node is any node you will take it up, and then this one port number of node. See here. This is
Oh,
the IP
okay.
address of node and port number, node port. You can access internally also. Curl HTTP 5678 5678. See, so this is the story of Kubernetes. Got it?
Yes.
So this is a very important topic for you.
So
You every
expose command, it will dynamically create
dynamically
load
label
balance.
the things.
Ah,
Yeah,
label the things. Okay. And
yeah.
load balancer will also be created, right? You no need to explicitly
No, load
create.
this third load balancer will not be created now because for this you need required EKS AKS. I did not use the EKS AKS service actually. This will not work in here. You can put it up load balancer, but it will not create because it will go to in the pending because connection
Oh,
of load cloud is not available in my cluster right now.
okay.
See, so here, see this got into pending external IP load balance.